Hey, welcome to Futurice. We're glad to have you here. We were started better with our meetup, so really got really short words about the Futurice and our PhotoCloud team. So which one is actually kind of like having this event happening helps. So we are really big company right now. We have 7 offices and different nationalities, and I've joined Futurice a little bit less than 1.5 years ago, and what I just will share with you what I'm learned for this time. So what I've learned so far is what the great part of this being a Futurice is. You can choose a team and a project. You can learn a lot about the things going on the projects you need to learn, and well, you select the things you would like to go further, to explore, to learn about. You have this cloud training, maybe the cloud training on the PhotoCloud part of our company going. So I think, at least for me, it's really interesting. Part of our culture is to share what we've learned, and we have these Photo Friday events on the Friday events to share that and share this in the company. And good thing that the transparency inside of the company, we share the projects we are doing right now, and we can not only from our for the separate teams, but the other different projects. So it's really kind of you can get a lot of this information and learn a lot of great things. So from the cloud perspective of our businesses, what I've learned that's really great, at least for me, is infrastructure as a code. We have had this Terraform infrastructure system going, so the cloud offering. So really interesting, and kind of Amazon is one of our biggest partners right now. Yeah, using the different technologies and Node.js, really a lot of this. Kotlin is coming strong. Clojure is really strong right now. So yeah, and we have these Friday events when we share the things we've learned, and we actually not only sharing this with inside, but we actually publishing it on this Futurice on the GitHub, and we have this podcast Futurice, the no ND, of course, part. So that's it. Yeah, Markus will talk about the PhotoCloud team we have.
Fantastic. Hello, my name is Markus Koskinen. I'll talk to you 3 or 4 minutes about our PhotoCloud cloud automation team. So. Last year, in March 2018, we founded a specialized team for cloud and DevOps, aiming to increase the cloud competence and provide specialists for project teams, work with cloud and CI/CD. We have 3 sort of main focuses at this point. So cloud advisory, which is the highest level thing to help enterprises shift their paradigms from the older stuff, cloud native and so on. DevOps, which is...
Yeah, can you speak louder, please?
Okay, great, fantastic. So, and then our second focus is DevOps, which is the more normal sort of working with infrastructure as code and Terraform and so on. So this is going into project teams at the beginning of the project, aiming to have everything infrastructure as code, CI/CD pipelines done, so that developers can start focus on coding, and we supply the infrastructure. Then also we're going into data architecture, so data lakes and AI ML stuff. We've been lucky to work with some fantastic clients: Supercell, Telia, the League of Ahti environments, Caruna Fuel, mostly AWS, some GCP and Azure. We're hiring, so please visit. There's a cloud architect position there. It mentions Azure, but we're hiring for all major clouds. So fantastic. That's it. I made it under 3 minutes, so good stuff. There's beer and cider in the kitchen and pizza, so please help yourself.
Introduction. I will have this presentation, little bit demo. Well, half an hour. Please bear with me. I don't know how much is. Yeah. So, who is using the step functions right now? Who was using? Who is? Yeah. Yeah. Okay. Great. Yeah. So yeah, my talk is about microservice orchestration. So and how we can use the step functions and orchestration as it is to kind of bring a difference to project we have. Yeah. And so that's kind of we have this foundation of the distributed architecture. And probably if you're using the lambdas, if you're using serverless, if you're using microservices, that implies what you have is distributed architecture because everything talks on the network. And the orchestration part and the important part of that is that there's in some of the projects there might be some think as a process called a process or a workflow. And why it's important? If you have something important to be done together, like for example, if we have this flight travel package or ordering, and you don't probably need for that example, you don't probably need only a flight or only a hotel. You need to order everything. And in that sense, there is a process of ordering all this travel package, which includes the hotel booking, the flight booking, and the rent a car. So in that sense, these might invoke this distributed architecture. For that example, you might have these third-party services and like on-premises something. So in that case, as we have this network, the multiple devices, everything can fail. The network can fail. The mobile application can stop working. The mobile phone can restart. So really important to have some approach to solve this problem when you need the consistency of the data you're having. So it's actually not a new problem. It's actually on the 1987. It was this white paper was published called Sagas, and it says that if you have a like not really if you have databases there, but it was enough distributed for the 87. Yeah, if you have this complex architecture and you have a business transactions which might invoke the multiple services or multiple different databases. And you need a consistency for that process. You need to choose carefully how you do the things. And there's ideas of using choreography or orchestration. They all have these downsides and pros and cons. So you need to choose. So what is the choreography part? Probably like the backend developers, the front-end developers, you are already doing that, because it's most common and obvious way. And you have this microservice architecture, and you just invoke it like all together from your application. And when every service you have knows about other services, and like the invocation part, the logic of ordering, for example, do you order hotel first or do you order flight first? It's inside of the application. And probably for some simple applications, that's fine. You can live with that. But if the logic inside of that gets complicated, it might be difficult to maintain that, to modify it. So one of the way of doing that, classical way, is, for example, if we have this mobile application, we might have this logic of invoking these specific services in the client, in the mobile or web application. And you can have a state machine like Redux, for example, and you can call all these services in the sequence you have. But there is a problem comes that how do you handle errors? How do you handle these transitions? Is there if there is some service doesn't respond in the specific time, there's timeout, how do you handle that? And it makes this state machine which you might have in the application really complicated. And if it's, for example, if you have this, something to pay for, and after that to deliver something, it gets really important to have the transaction inside of it, like some sort of a transaction, because you don't want to person to pay for something and not deliver them this. So it shouldn't be lost on this mobile device. And of course, there is a part of this called this. You might want some of these services to be inside of your infrastructure. You don't want to expose them. You might don't want to have all this data you have passed from one service to another visible to the client, because basically if you have Android application, the person might find all these communications you're going quite easily. Another thing to consider that if you have this logic of sequence of invocations of the microservices encoded and embedded into the mobile application, it's up to the user when he updates the application, and the workflow you have this way defined. Well, you cannot easily change. Yeah. And the other way of doing that is it's actually kind of common pattern right now. It's a backend for front ends. So you might have the internal services, which is for a hotel, for a flight, for a rent-a-car, and you might have this backend in the middle between the mobile application and the microservices, which actually have this logic defined in the code to call these specific services. But the thing is, when you order a hotel and there is error comes, you can cancel that hotel and that's it. But if you need to order a flight and you have already a hotel, you need to cancel the hotel because you don't want to have this hotel still keeping in the system. And if you have a rent-a-car, you might need to cancel a flight and the hotel too. So that gets complicated because you want complete trip or nothing. So that's what, in that sense, there's a transaction. So if you have it in the code, it will be hard-coded in the code, and it's not easy to change. Probably you can do it by doing the new version of the application with the backend. From the serverless side, it's not so good idea, because when you have this backend as a serverless application, as a Lambda, and it calls other Lambdas, you basically pay twice the price for the time when this backend waits for these microservices to respond. So it's might be expensive. And there is other thing is to consider that timeouts. You have these limits for time of execution lambda, so it can be a problem too. Our way of doing that was really popular in enterprise. It's called Enterprise Service Bus, and you can orchestrate. You can have it as a choreography or orchestration in the queues using the queue message queues. So basically, when you order the hotel, you can put this message in the queue. When you order a flight, you read this message from the queue to order the flight. If you have a problem with this, you put the message into another queue and have it processed by another service. That's doable, but it can be the problem with that. It's you are having this workflow defined by this logic of connecting these queues, how you connect these queues to the consumers of these queues. So it might be difficult to do and might difficult to change, because you need to change infrastructure basically, not the application you are having. It can be difficult to track single order you have, because you need to take a look at the queues, you need to take a look at the applications, so it might be difficult. But the good thing about this, you can scale, you can have the microservices on each side have been scaling as much as you can, so it doesn't, in that sense, is good. So there is the Saga's white paper defines our way of doing that. It's called orchestration. And the orchestration basically means that you have one central pod inside of between the front end, between the clients of your application, between probably from, you can also invoke it from backend, and this orchestrator does these invocations of all your microservices you needed for the specific process you have. And it does this error handling, retries if needed, and it encapsulates this workflow logic you have. In some sense, you have this central part which the execution is contained within. So from the mobile application, you just put it, make this order, this hotel, then this car with this flight, and after that you keep it, the orchestrator does this thing asynchronously. So other things is microservices you might have on the Lambdas, they became more simple because the only job, the hotel microservice, the only job is to either order the hotel or cancel the hotel, and that's it. It doesn't need to know about any other services they're having. The other thing is that thanks to the centralized orchestrator, you have this information about which microservices was invoked when, and what was with time, what was input, what was output. So, and as you have this one single point of deploying this workflow, it might be more easier to change it. So you don't need to change the specific microservice you're having. You can change only workflow, make other logic. For example, order another car, have another microservice deployed for another car rental company. So if done, the orchestration really depends on the engine you're using. So this part which do this central, the orchestration part. And if it's reliable, reliability is implemented by using this error control, the retries for the microservices called. As I said, this simplifies microservices and makes them more, kind of universal, like a component. The product level processes you might have for that, for your project, for your application, they became more transparent thanks to the history of all the executions you might have. And this transparency part, the bad things about this is probably the complexity of infrastructure you are having increases. You might need to find a way to test that. So it's not enough to test only the microservices. You also need to test the workflow, the process you are having, and that might be more difficult than the regular way. And yeah, probably it's involves learning new library and user language, interface language, because this orchestration engines, sometimes they use this special visual language to define what workflow you're having. And this visual language we have, it's probably it's a good thing and it's a bad thing, because yeah, you need to learn that, but it defines you like some way of expressing what the process you have on your product level. So the way of doing that is, for example, Amazon Step functions have it on the as a graph, and other engines they have this as business process management notation, which have the specific blocks you can use to build this. And it's actually what I've learned from my experiences. It's actually easy to train like all the stakeholders you have on a project, and they can use these models, the visual workflow models, to talk about the project they're having, the process we are implementing right now. And if they have this, for all these blocks, we have the history recorded, what have done, if there was errors, how many times every block was executing. We can use this information to understand what is the weakest part of our application, what we can scale, not based on, not only using the data, and using this data in real time, you can use that to scale to change your infrastructure. And you can separate the business errors from the network connection problems. You can record it in the history. So going to the Amazon Step functions, and this service was for quite a while, and it's a hosted service in the region. It provides you from the you can have the history on different levels. You can see every process you have executed. You can see what the microservices you have, what have been called, what was input and what was output of that. The other thing is that you did these workflows from the console. You don't need. You can deploy it, of course, using the infrastructure tools, but you can start with it's easier to edit online on this. There is a really comprehensive error handling. So, for example, if you have lambdas and you can define different errors in the lambdas returns, and you can react on these errors different ways. So, if you order flight, you can, for example, retry, or you can cancel all this sequence if there's you cannot order this flight right now. Yeah. And the lambdas as a first class, you actually don't need to expose the lambdas invoked through the step functions on the API gateway or the outside world. If they used only by step functions, you can invoke them directly from this. And there is different Amazon services supported for the inside of this workflow of the step functions to be called. Like you can use the DynamoDB, you can invoke the forgate task to start service to start. Well, that might quite take a while, and you can publish the message to the queues. And the other thing, you can integrate with the third-party services, which is not really kind of ready for that, like third-party ones on external to the Amazon infrastructure. So there's a lot of different ways of using that. And, well, for example, this follow-up email, you can use that. It's actually like I learned yesterday. So basically, you have per person to sign up for your application or your website. You can post the message you can start the workflow that will alert the person in 5 days about how are you doing, everything fine. But if person deletes his account, you can cancel that workflow, and that's one of the great examples, yeah. But people using this for continuous delivery, like for a different infrastructure, really complicated one, if you're not comfortable with build code pipeline, for example, or like other like outside services. Yeah, and I've created this demo application. It's actually specifically for the orchestration, for the microservice orchestration pod, which does image recognition based on the Amazon infrastructure recognition service, and generates thumbnail and loads it into the application. So how it built? They have this static web app. They have the S3 bucket to upload its image. When you upload this image, the new workflow starts immediately at this point. And it invokes first Amazon recognition service to detect face and smile of the person. After that, it calls microservice to extract the face, only the image of the face of a person, and put it onto this S3 bucket. And at the end, it using the Google Cloud Messaging. Somehow I used this one more familiar for me. So it on all the steps of this process, it invokes the Google Cloud Messaging to notify synchronously the web application and the user about the progress of the things are going. Yeah. I will. From this slide, will be starting the demo. So yeah. So can you hear it? Oh yeah. Can you see it? Is it? Can it bigger? Yeah. Just a moment. Yeah. How to do? No, it's a mobile application, so that's I don't see how it can look. Yeah. So the idea is that you can upload the image of the person, and recognition, Amazon recognition allows you to detect the face and does the person smile or not. So in that sense, what we're doing that we take this image, for example, it's Unsplash images, and we take this person, and it's it uploads the image to the S3 and sends us a message. Okay, that was uploaded, and after that it tries to find the face and the smile, calls the recognition. After that, it extracts the specific part of the image which have this face of the person. So you shouldn't. You don't need to be at the center of the image. Yeah. Okay. Yeah. Let's try with three people. I don't know whom it will select, because you cannot. At least I haven't found a way to control how the specific person it selects have its own. So this but somehow not smiling. I don't. Yeah. So how it works, and they have this. Can you see it from Marcia? Yeah. Okay. Kiitos. So we have this workflow defined in the Amazon state machines. They call it a state machine, but basically there's a lot of these terms generated over the years. There's work process, workflow. So yeah, and it starts as soon as the image goes to the S3, and you can see that there is a history of every execution happened at the application. It shows you when it started, when it was finished. Like now, it was well, quite long one, 7 seconds. Yeah. So, and you can take a look at the execution, and you can see the execution path what was taken for their specific image there. So it's invoked find face. So the lambda which calls the recognition part. After that, it sent the message to the application, say, yeah, we have found the face, and it provides actually not. Of course, we don't have any image of the face before that, but it says, yeah, there was a smile, or else was not. After that, it calls the resize function, which is not only resizing but extracting the cropping to the face person, and it calls the notify resize again. So that's how it works, and it shows it here. Do I have an errors here? I don't know. I don't know. I don't have. So you can see this workflow and edit it directly from the. Sorry for this. Yeah. So you can the language to define these workflows is a JSON, and it basically the list of the steps inside of this workflow connected by the kind of the parameter. What is the next step we need to invoke? So what I want to do right now is to add the new one step. And what I would like to do is right now there is nothing stored in this thumbnail when we upload this to application. If we reload the app, it doesn't have any state. It's just have it like as you haven't updated anything. But you can add the part to save it and directly call the DynamoDB to update this. To save this thumbnail. Actually, I have this prepared the part of this. So what I'm doing is I have this step defined update DynamoDB item, and it's directly from this workflow calls this calls the DynamoDB to save the image of the thumbnail we have generated. Now, as you see, it's not connected to anything. It's just like after that, it calls notify resize, but we need to connect it to the. What I would like to do is connect it after resize. So you can define you can online just after change you can update this workflow picture and see how it goes. So after resize, it will update DynamoDB, and after that, it will notify and show us in the application. Yeah, it was updated. So yeah, let's start again. So we can start again. You don't need to do anything with our application, because what we are doing is on the Amazon side, and you just say, yeah, what's this image? Just give us the notifications and the result, and all the changes is happening at the workflow side. So yeah, we can, for example, we take this one. Yeah, and find the face and done resize it. Basically, same idea. But the part is, we can take a look at this Amazon Step Functions interface and the executions we have had. And this is the latest one. And let's check. Yeah, it was called, this green one. And it saved this image. If I reload this application, it fetches this image from the DynamoDB. So basically, you have this web application, like a web application working as it should be. The microservices, they don't know about Everflow anything, and you connect them by using these step functions to do this real part. So yeah, I will continue. So actually, I haven't said that. You can try it yourself on this URL. Yeah, I have it. Yeah, I don't know. But yeah, I'm uploading my own picture, but I don't want to be this. GDPR. You probably should use some like Unsplash one. Yeah, but I have this TTL of 2 days, and it removes everything. Yeah. So. Yeah, just like if the demo is not working, yeah, I have this slide here. Yeah, so for example, what we have do these improvements, which might involve little bit of this microservice or web application changes, but a really great deal of the other things changes. For example, the AWS recognition service, they have this celebrity recognition feature. I haven't tried it myself, but idea, if you have this social app and you upload the image of a person just registered like 2 days ago, uploads the picture of this celebrity, so probably you would like to send the message to the administrators, something is, probably it's a fake profile. So you can do it, and you don't need to modify existing services, because the step functions workflow can have conditions inside of that, and you can just react on these conditions. So yeah, celebrity found. Let's call this service to send a message to administrator. And other thing, you can have your own private face recognition algorithm, or like virtual machine, or like something, and you can run them in parallel and have all these results from the recognition from your virtual machine recorded, and after this way you can compare, and if everything goes well, you can or can make a canary release, or like switch completely to your own. So that's kind of a way of doing that. Yeah, and I think this almost final one, and the idea of this orchestration and step functions, it's a product level or team level feature. You are not making the changes to the microservices. You have all this process defined inside of this, and define this logic on the bigger level, higher level. So that's it. Yeah. Thanks for your attention. Yeah. You can find this presentation like on this address, and you can have a fan face, Ruslan.org. There's a link to the open source. The GitHub has always part of this on the GitHub. So yeah, you're welcome. Yeah, sure. Just where is this? Yeah. Yeah. Who's? Yeah.
It's a bit strange to me. Can you hear me? Can you hear me? Yeah. Actually, these step functions, I tried it around 1 year ago. Mm-hmm. As far as I remember, it wasn't that straightforward to transfer result from one microservice to the other one, for example, and it wasn't designed for that. And I think it hasn't changed. Correct me if I'm wrong. Let's say that now, for example, upon user request, we have a Lambda function that processes it. and then the Lambda function calls a third-party service outside AWS, and we would like to return the result of that third-party service to the user, okay, to the customer. And we want to orchestrate this with step functions. How can we do this transferring result from, because firstly we should transfer from Lambda to that third-party service and from third-party service to end user. And we want to notify him when it's done, and it should be asynchronous because it can take a long time. How would you do that?
So I don't know what was 1 year ago, but now what I know right now. So there is a part called input and output transformation. So you can compose the input and output of this before you invoke the other party service, you can transform the things that we send to. Of course, it's JSON. You need to have this as a JSON defined. So you can transform that, and when you return the result from that microservice or something, you can transform the place you store it inside of your kind of the workflow have this global state of this one single execution, and you can before you invoke, take the specific part of what you want to send it to this application, to this microservice. After you invoked, you can put another specific part. What I'm doing actually here is result path. It allows you to select where would you like to put the result of this. So that's at least. But you're right. You are completely right about this asynchronous part. The orchestration part. Orchestration way of doing things implies you need to use the asynchronous way of doing things. It's one of the reasons why I'm using Google Cloud Messaging. So you have this input all the time, constantly from this.
So basically, based on what actually input and output was there 1 year ago, but there had limitation about the size, which practically meant that there is not much can be transferred. So if I understood you correctly, you mean that you put your process result somewhere, you store it either in database or in EC2, whatever, somewhere that you can retrieve it, and whenever it's processed, you update it, and then you return that to the user. Is it what you meant?
Yeah, correct.
Yeah, okay, so it still is like that, okay.
Yeah.
So, thank you. Yeah.
Any questions? Sorry, I'm not comfortable with throwing this.
Thanks. So let's say I've ordered a hotel, and then the next phase causes an error, and then the canceling a hotel starts. So what happens if the canceling causes an error? Can we survive that?
So yeah, that's kind of a question. It's in Saga. They have this in Sagas with papers have this. So if you have this regular happy flow, all fine, but you have in the cancellation flow you have something bad. What you should do? And they say, yeah, problem. There is a problem. So the idea is that the cancel function, you might retry that. You might react have this, try again or call another service, but probably that involves, if you have this cancellation logic having problems, you might be difficult you need to, maybe sometimes a manual intervention is needed. So that's kind of it depends on the way of the task, because idea is that you have this global transaction, distributed transaction basically. And yeah, if you cannot cancel that, what you should do, that's an unpredictable state of the things, yeah.
Actually, to address this, 1 month ago I was in a presentation in a bank. They were wanting to handle this kind of thing. There is something called self-contained system or self-contained architecture. They have really tried to handle this kind of situation that I'm sure it can be extended even to cancellation, that if one microservice completely fails, how you can make the whole system immune. And they have handled in a way that they divide the system into different self-contained systems. And each of them is independent from the other one, and it retries as far as it really succeeds. And if it doesn't succeed, it will retry for that, and it's more immune. You can Google this, and maybe you will find it interesting.
Okay, thanks.
Questions? More?
I can ask another one.
Yeah, great.
In slides, it seems that the same Lambda had both the ordering and canceling. Why is this so?
You mean this one?
Yes. Is it better to separate those?
But the idea is that I'm grouping them by hotel API. So you can group it whatever like way.
So you think it's better to be separate?
If you do this serverless way, yes, of course, that implies you have this the order hotel order, you have Lambda. Order cancel, you have Lambda. If you have these microservices, or the idea is that one microservice do one thing, and probably it involves both the ordering the hotel and canceling the hotel. So it depends on the architecture you are having. So that's the way. But of course, the cancel part is really important to be done properly, and so it should be kind of quite near, closer to the ordering part, right? That in that sense, it's here in the same place. Yeah.
Okay, I have a third one. When we are using this step function service in Amazon, where is the actual data? Are lambdas just passing some package of data to each other, or is this step function service taking care of that?
So when you start with workflow, I can show actually, I think. No. Start execution. So when you start, you have this initial data defined. Initial part of this input called. And then you call the different microservices inside of that, like this workflow is going. It's like brings more data inside. Of course, there are limitations on the amount of data. And the general rule for the orchestration part is that you don't keep all the data inside. And that's a kind of like, there's limit like 32, 4 kilobytes, quite low, yeah. And because it's actually like really kind of obvious question, how we manage. Better to manage it inside of the other microservice. You have this database defined, which have this, because the problem, the other thing to consider that you might have one travel, but you might have different travels. You might have the travel connected to another travel. So probably the travel, for example, for this history, for the travel package example, you might have the different objects in database. So you need to have it in some other database. And the microservice part, which saves to that database, might be a part of the step functions you have.
Okay.
And I think actually they have done this limitation intentionally to force us to have trace and really think in a trace way. So always an ID associated with that.
Yeah, true.
That's all from me for now.
Yeah, sure.
So how would you test this?
Yeah, that's the hardest part. Yeah, it depends on the engine and on the step functions. I haven't researched it myself. So I think there should be ways. But the idea is that you have the idea that you should test my microservices, and probably if you have microservice like service of lambdas, you have this already. And the workflow you need to test independently of our microservices. Of course, there might be a way of integration testing, end-to-end testing, that everything is tested. But the idea is that you have the workflow in the steps you are heading them. You don't really test call this specific service. You call the emulator of these specific microservices which have expected behavior. At least what I would like to do myself. I haven't researched a specific, step functions way of doing that. Maybe there is some library, but I'm not ready to discuss that right now. But you test the process and you test the microservices, and after that you have the end-to-end testing of everything together. So that's kind of a way.
So if there are no more questions, we can have a 15-minute break. Around 7:05 we are back with the next part. Thank you.
Thank you.
Okay, so I'm Jouni Luoma. Nice to see you all here. Good Good evening. So, a little bit outline for this presentation. Just a short intro. Then I will talk. This microphone is triple. I will talk something about the AWS DeepRacer, what it is. Then a couple of short slides about reinforcement learning in general. Then how to build a model, how to run the simulator, what's the differences between reality and the simulator, and then a little bit about the race in Stockholm. It was a couple of weeks ago. So here we are. So again, my name is Jouni Luoma, and I won the DeepRacer League competition in Stockholm AWS Summit on 22nd of May 2019. The winning time there was 8.7 seconds. And what about me? I have some experience in AWS environment. I'm not an expert. There's lots of other guys who does it better. I tinker around, but I'm not an expert there. A little bit more experience in machine learning and over 15 years experience in IT consulting business in general. And my experience with DeepRacer was 2 weeks before the summit in Stockholm. So what is AWS DeepRacer? How many of you have tested it, tried it, know it anyway? Yeah. Okay, so let's start about what it is. So in a sense, it's a three things. So first of all, it's a 1/18 scale race car driven by reinforcement learning. So it's a what it actually is, it's a like radio-controlled car chassis with some computer bolted on it and a camera. Then it's also had 3D racing simulator because the reinforcement learning, you don't actually train these AI models. You train them in a simulator. You don't train them in a car, or you don't train them in with like footage from the camera at all. And then also, it is a global racing league. And there's a link to the DeepRacer. Go and check out later today, or maybe over the weekend. So a little bit deeper. So the DeepRacer car, it just runs inference. Do you know what inference means? Okay. Inference means that if you have a like machine learning model, it means that you don't train the model at all, but you just use it. So you just put some numbers, you put some inputs in, you get outputs out. That's inference, and that you can do normally in a like smaller, more not that powerful computers. But normally, when you do training, you need a little bit more horsepower than, for example, a computer that's just bolted on a small RC car. And the DeepRacer car, it just runs inference on images captured from the onboard camera. And the model, which we put to the computer, it defines the actions, what the car does. So what speed it drives and how it steers. Then there's a DeepRacer service, it's an AWS service. So the DeepRacer console is a service for training the model, but the DeepRacer console actually uses AWS RoboMaker, which provides the simulation environment, and we get the data for the training from that simulation environment. And it uses AWS SageMaker to do training the neural network for the car. So the model we are using with the car. And DeepRacer League is a competition. It's on real track and cars in AWS summits. And they also have a virtual league, which is run in the simulator, so everybody can attend. If you are not going to summits, you can still attend to the competition. I can show this later on. So, okay, there's a little bit more specifications about the car. I'm not going to read those out, but anyway. Okay, it's an open Wino toolkit. It's just the Intel toolkit for inference. So calculating these kind of matrix calculations, what you normally do when you use neural networks. And robotic operating system for controlling the car. And then there's a little bit nudity and engineer born here. So when you strip off the it's just a plastic cover. So there you can see there's a camera bolted on. There's battery. There's computer. There's also a different battery for the RC car underneath that you are using when you're driving. That's just computer battery there on top. And by the way, if you have some questions, please ask anytime. Yeah. Sure.
Actually, I have seen this car in our office, and I was wondering what is the thanks for answering this question. I'm wondering, in order to use DeepRacer service of AWS, you should always have you should buy this car, or?
No, it's just a service. You can try it out, and you can participate to virtual competition and virtual league already without having the car. Actually, in the AWS summit, you even didn't, you wasn't allowed to use your own car. You just had to go there, bring your own model, and they gave you a random car that no one can tune their car to be better than the others. So in a sense, you don't need a car to start, but of course, you would need a car if you want to see some kind of real life action. Well, the training doesn't happen in a car at all. The training happens only in a simulator. But yeah, I will come to that a little bit later.
And just in order to win and attend this league, do you need to have any technical skill or just gaming skill? How is it?
Well, it helps if you have some technical skills. It's not just gaming, but we'll come to that maybe a little after a while. So, there's what a DeepRacer 3D racing simulator is. And actually, this is the simulator 1. You can start the training here. You should see the simulation video stream here, but normally it doesn't work. So I go to Kinesis video streams, and I see the preview there. So you can look at Kinesis video streams. I showed it. It was just playing here, and you see how the training is progressing here. So you see how you get rewards over time. So how they are growing over time. But that's a short one. Yeah, and a little bit again about the racing league. So there's a link to the racing league. There's currently a race going on with Kumo Torakku race. I was third in the race yesterday evening. I think I'm fifth at the moment there, but it's open still maybe 17 days now. So, a little bit about reinforcement learning, because the DeepRacer runs with reinforcement learning. How many of you know what it is? Okay. Good. Well, anyway, just some basics. So, reinforcement learning, it's a one type of machine learning. It's along supervised and unsupervised learning. And in short, reinforcement learning is study of agents and how they learn by trial and error. And it formalizes the idea of rewarding or punishing an agent to make it more likely to repeat or avoid certain behavior in the future. And how this happens. So if you look any presentations on reinforcement learning, you're probably going to see this kind of graph over there. So in reinforcement learning, when you train the agent, so the agent, this is about reinforcement learning training, how you train those. So the agent interacts with the environment, and every step, agent gets the observation of the state of the environment. It can be fully observed if you get every possible detail of info, how the environment is, what the state of the environment is. In normal cases, we are talking about partially observed state. So this happens, for example, in this car. Your observation is a one image, and the car should make some kind of decision what to do based on that one image. So it really don't know the whole world or whole environment where it works. It knows only the image. And yeah, the agent decides an action based on the observation, and the action taken is based on policy. And this policy is normally, it can be anything, any program, but it's quite normal to have it's some kind of neural network working as a policy. And you use the outputs of the neural network to make decisions what the agent should do. And after this we're going on and on. Agent gets new observation and a reward. And the goal for the agent is to maximize the cumulative reward it gets. And these kind of trainings, they go in episodes that they start somewhere and the episode ends probably, for example, with this car example, one episode ends when the car runs out of the circuit, or if the car completes a full lap. That's also episode end. So it runs only on one episode at a time, and it tries to accumulate as much rewards during that episode. So, building a model. So your job in building a model is select the action space for your model. Action space is something, those are the actions, what the agent can take. In this car example, it is, for example, that drive directly straight ahead with speed 2, with speed 3, with speed 4, for example, or turn to right with different speeds, turn to left, different speeds. And the size of action space, you can set it yourself so that it suits your purpose, but the larger action space you take, the longer you will train the model. Because in the beginning of the training, it randomly tries different kind of options from the action space. That okay, how would this work, how would that work, how would this work. And if you have a really large action space, it will take time to convert to some kind of usable model. Then your job is to provide a logic how the agent, the car in this time, how it gets the rewards. So you provide a reward function telling that when the car gets a reward and when not, and provide hyperparameters for the training of the model. And the AWS DeepRacer console or the DeepRacer service, it takes care of the rest. So it's used to start and evaluate the training. It starts the RoboMaker for simulating the driving, and the data for the neural network training comes from the RoboMaker. It starts SageMaker for training the model. It starts Kinesis video streams for you to get visual feedback. You get CloudWatch logs of the training events. You probably cannot see here how much time I have used, so I just know. Yeah. Okay. Anyway, well, building a model, I just took a couple of pictures from the DeepRacer service. So here you can set the action space as I told you. You can take a track for which you want to do the learning, so or the training. You can use the same models in different tracks, but they might not perform that well in all the tracks if you train it to just specifically for one track. And these are the parts for the rewarding function. So this is what you get from the simulation environment. So you get an info of like, are all the wheels of the car on track? And what's the position of the car? How far from the center of the track the car is? Is it left of the center? Where it's heading? The progress tells you how much of the track, the percentage of the track, how much it has driven around starting from the starting point of the track. Steps is one indicator. So one indicator of how much time it has spent on the track. So step is actually, as I showed you the graph. So one step is like a one action that it makes an action, gets a new state, and it gets a reward. So those are one cycle is one step, and it tells you how many steps it has spent on the track. It tells you speed, steering angle, track width. Also, waypoint, it has coordinates on the track, so some so-called waypoints around the track that, okay, I'm near this and this waypoint at the moment, but I haven't really used those waypoints, at least in a sense that, okay, now it's in this part of the track, I want you to do this and that. I don't use those, but someone might use. And it says what's the closest waypoints of the car are. And those are the building blocks for your reward function. In the beginning, your reward function could be something like that. Every time you're just on the track and not outside of track, you get 1 point. And in the end, it learns to drive around the track, but it probably just going to zigzag along the track all the time. And with these building blocks, you just make the function for yourself. Okay, this also doesn't probably see, it's not visible that far, but it's one of the example models of AWS is something that, okay, if it's almost in the middle of a track, so you get more points, and then if it's like halfway from the center to the track edge, it gets a little bit less points, and if it's almost on the track edge, it gets even less points. And this should learn to drive around the track, hopefully in the middle of the track. So then about actual experiences. So learning about this, they had a small video tutorials in AWS, maybe 40 minutes or 1 hour. I watched those, started tinkering around, trained my first model. It did some like 45-second laps in the simulator. And the fastest lap times on real track were about 8 seconds at that point. So if I was going to compete in Stockholm, it didn't look that good, you know. So I continued training, tested a little bit different kind of reward functions, gave some more rewards for the speed, trained with faster speeds. I think that when I first started, I just used some kind of default action space, and its top speed was quite low. So I had to ramp up the speed a little bit to get better times in simulator. I got to around 20 seconds a lap, and well, it wasn't still good. And I continued training, and I got to somewhere like 12 seconds a lap speeds, and thought that, okay, it's still far away from 8 seconds, and how these guys are doing it. And then was looking at the logs that, okay, my car actually drives at the top speed all the time, and it has a really good lines on the track, so what happens? And what happens, it turns out that there's a little bit difference between the real race, like reality race car, and the simulator. And this is quite normal for reinforcement learning overall. It's called, well, not only this kind of that there's some seconds difference, but it's called reality gap. So when you take your model from simulator and put it to a real car, it might not behave as good as it behaves in a simulator. So a little bit about reality versus simulation. I think it was 1 week before the summit, we got our track to our office. It was pretty huge. I did just put some furniture, moving tray. Not everybody was happy about it. I was blocking the walkways there and like putting in barriers that, hey, please don't come here. It is really massive, the track, and we really didn't have that space. But we got it unfolded eventually, and it was good enough, so let's try. So this is a control vehicle dashboard. So you get access, network access. So you just start the car, and it has a server, like like web server in the car, and it provides you with a video stream of the car. And for example, you can upload your models to the car. You have to do some calibration of the car, put some settings there, for example, network settings in that car, and such stuff, and you control it there. So uploaded some models. Okay. So this is something, what happens first? And Okay, we got it running also full better laps, but it wasn't that often it happened. So it was because I had a really nice models in simulator. They were like always doing 100% laps. They were running fast times, and then you put them out on the real track, and it just like drives all over the place. So what happened? This is the reality gap, or the simulation versus reality. Okay. And for first of all, of course, we didn't have a visual borders around the track. So if you read the AWS instructions, they instruct that, okay, you shouldn't have anything other white, for example, around your track than the track lines. So the borderlines of your track, and you shouldn't have like any, well, hopefully any movement and different kind of shadows and things around. So we put the visual borders there. I tried different models at the same time. Well, we had also these kind of huge windows. They were nice, sun shining to the track, and it was shining all over the place. The material was such that it made lots of reflections. It was difficult to go there. Yeah, built the visual borders. I bought some like this kind of gardening fabric you put over your plants, or like under plants to like cover the earth, something black, because it was cheap and there was lots of it in in a one package. So just laid it over the office chairs to get these kind of visual borders there. We even tried to add a polarizing filter to the camera, so we just had some tape and put it on the camera lens, because we thought that, okay, it might help with this kind of reflections from our track surface, because we knew that the AWS Summit track, it's a little bit different kind of material, so it won't have this kind of reflections. So we wanted to test that, okay, can we get a car to run at least somehow similar way that it will run on the AWS circuit. And after a while, I got a couple of models that were doing full laps. Not all of the laps, but still like a quite robust full laps. So it's like not all the time crashing around, because some models were just that you get 1/3 of a lap and it always crashes in the same place. So the week was over. We were heading for the race in Stockholm. So the summit opened at 7:45. I knew that in London they had quite long queues to the track. So my strategy was that, okay, I will be there early, and I try to get my best times in the beginning of the day. And so I was, doors opened 7:45. At 8 o'clock I was on the track. I think they were still just putting up the places that, okay, we are not ready, but hey, you can come. I started it. The race in the summit, it's something like a fastest lap counts. So every developer has 4 minutes on the track at a time. You can go as many times as you want, but you have to queue always. It was good that in Stockholm they didn't have that much queues. I think a couple of guys I have a talk about DeepRacer. They were in Tokyo yesterday, and something like said that there's like 2 or 3 hours waiting for the track, so you don't really have that many times to go. I took maybe 10 to 15 turns on the track during the day. Anyway, 11-second lap on the first time, so it was pretty good. I had looked earlier earlier summit scores or summit times, and I was confident that okay, this will land me in the top 10, and top 10 gets a free DeepRacer for themselves as a prize. So okay, I was happy. I will get the DeepRacer. That's good. That was something I was hoping and I was targeting for. That okay, I will be in top 10. And I stayed at the top for 1 or 2 hours. Maybe raced one other time there, but didn't have hurry. But then the competitors got out, and there were a couple of this, like top 5 was really tight, and every time there was someone from the top 5 on the track, it felt like, okay, they can make a better time than me, they can make a better time than me, because the cars were really fast, but it was the same for everybody. The fast models, they are not stable. So when you drive really fast, so they normally drive out at some place. So you... oh, I forgot to say one thing. There's like hardware gas also in this RC car. So you can select the maximum speed from the hardware, and like AI model handles the speed in the limit of the maximum speed of the car. But it was something like you could set to get laps at all, you could set the maximum speed to somewhere like 50 to 60% from the maximum. If you set it to 100%, it was like first fall you can get, and it's driving straight to the first wall. But anyway, so I was hitting the queue again. Found one model which was really fast, but quite unstable. And I think I got only a couple of full laps during that 4-minute session. I ran with that model, but one of those was fast enough. So it was like 8.7 seconds, which I guess is still the European record. Not the world record anymore, but the European record. Yay. So after that, it was just like waiting and, what are the other guys doing? So I was, waiting and hitting the queue again, waiting and hitting the queue again, because every time the other guys came there, I had to go also and try to get a better time. And I think this lasted for 5 hours or something. Maybe I got to eat something in the middle of it, but really I took like 10 to 15 times on the track during that day. But I couldn't get a better time anymore after the morning. So I think the best time was somewhere around 11 a.m. to noon time. But because the other guys, they seemed that their models were so fast, I had to try always again and again. That I wasn't safe. This is one video. This is not the fastest lap. I think no one was recording there, but I think this is the first one, because this is somewhere around 11 seconds. Somewhere around 11 seconds, the full lap here. I think I'm pushing the gas now, because it starts to go faster in the end. That's how it looks. And that was about it. 5 hours sitting there and waiting, watching that, okay, how the other guys are doing.
Jouni has been leading this field for just about 5 hours right now with an 8.732 second lap. He's watching on.
Yeah, I think
Knock him out of the top spot. Over a minute off the clock already.
Yeah, I think the Amy who was driving there now, she was, I think, the last one. I think she was second or third at the moment, something like with half second slower time at that point. And well, I'm anxiously waiting that her time runs out. And I guess this is the just video from her last lap.
One last lap, under 10 seconds left in the run. It's got to be now or never. Can Amy do something with Jouni? Jouni is going to be the Stockholm champion. A valiant effort from Amy. She moves up in second. Charlie completed the podium in third.
Okay.
Now, her best time at only.
That's about it. Thank you. Okay, questions? Chair?
What?
First of all, congratulations for your victory. I was just curious to know, because about like in 2008, I was participating in some robotics competitions, and this is like line follower bots, and we used to build our own hardware, and it was programmed with like embedded C on microcontrollers. So I'm trying to understand like what AWS is bringing new to these things, because in 2008 when we were programming these, they were much faster than what I even see now. So what is like the machine learning part in this, and what have you experienced?
Yes, so I think I know about this. This is RoboMouse or something.
Yeah, it's like Robocon, which is like
Robocon, but yeah, I've heard about these competitions as well, and I think I also was at the university like 20 years ago, and they had like some kind of courses on embedded development, and they had a like racing car which was following a line. Yeah. But in a sense, this is a little bit different. That this uses as an input like camera image from the environment, and in a sense, it's not only following lines. It learns to follow the lines, but it's you can train it to follow whatever kind of input. Shouldn't drink cola before speaking. But you can like train it to learn some other functions as well. So it's not really a following line. Actually, if you look at it, it's not following the center line at all. So I think what is kind of these robots that follow the central line, they are having like I think they are having just camera, and they some kind of sense it that where in the picture the line is, and if it loses the line completely, it probably runs out. So it's not going to come back. But
so is it like this kind of a bot can train itself while it is running, and can it learn on its own?
Not at the moment, because you have to like. These are trained, as I said earlier, these are trained in a simulator. So you have to provide some kind of rewarding function from the simulation that, in a sense, the agent in a simulator, it trains by its own. So it's just going there on its own, but you have to provide some logic how it gets the rewards. For example, if you think, well, reinforcement learning, they have mastered some computer games, StarCraft and Dota and such with that. So in a sense, they have some kind of scoring system. They give scores from some actions. So it's a bit similar in a simulator. So you have to find the logic when to give scores to the agent, and the agent learns by itself how to best collect the scores in the simulator.
All right. Thank you.
I just like to comment that the point with AWS in this is not to race, is to introduce performance learning to everybody. So it's not about the cars that much.
Yeah, so that's true. So this is a marketing stuff. The car itself, it's just it's a fun way to show what you can do, but in a sense, it's not useful or anything.
The other thing, the way these systems always work is that the machine doing the inference is optimized for inference, and the learning happens on a machine that's optimized for learning. So it's totally different hardware, totally different optimization for all of it. How you get data and how you process it. So if you looked at, for example, Tesla's AI Day, the machine that they have is really super optimized just for doing inference, and they can do thousands of frames a second.
Yeah, and they have lots of more horsepower, not some kind of Raspberry Pi or some cheap atom-based computer on an RC car.
This one still has that Intel inference optimized libraries, and the Atom and all of that is really optimized for the inference, for that low power inference.
Yeah, I think it has something like 15 frames inference, or 10 to 15 frames inference per second with this OpenVINO kit.
One more question, and then we stay for the break. You can ask him more questions. Can I throw it?
Yeah. Can you say that if I want to participate, or like my friends want to participate in this DeepRacer, if you create a new Amazon account, how much does it cost to learn these models? How expensive it is for the regular person?
It is expensive. Yeah, but actually either there's some kind of mistake, or they just increased the prices last week, because I was training one day models, and the costs doubled in a one day from the earlier.
But how much in absolute numbers?
It was something like $5 to $10 per hour of training.
Mm-hmm. And how much training did you have had?
Well, just with some hundreds of dollars, let's say.
Yeah. Okay, yeah. So it's kind of corporate stuff.
But actually, I'm now part of this kind of DeepRacer guys Slack channel, and they have had their own local, I don't know how, but they have some kind of local setup of SageMaker and stuff, so they can do local training without AWS. I shouldn't say that, but they still have done it.
Thanks.
So it's possible also to do locally, but you have to probably work it out for a little while. So let's check how our model is running at the moment. Has it learned anything? Not yet.
Meanwhile, I have a question.
Yes.
Okay. Do you have any figures about the inference milliseconds that required here? I mean, if we, for example, offload the model somewhere, how much milliseconds required for properly making the inference? Do we have roughly figures about this? Do you think so?
When I said that, so inference speed.
Yeah, inference speed has to be, how much milliseconds has to be there, or
what's how much it is? 50 milliseconds if it's, no, it's a little bit more. Maybe 50 to 100 milliseconds, because the DeepRacer card does like 10 to 15 frames per second, so the inference speed is
Okay.
around that.
And what about we can also install a SIM card to do that car, or it using the Wi-Fi? Or
Sorry?
We can install the SIM card in the
I don't
car,
think-
or it is using the Wi-Fi or kind of thing.
It uses the Wi-Fi, at least. What I know, I think there's no SIM card place.
Okay, thank you.
I think this is the last question, but I think Jouni can stay a little bit more if you have more questions. I don't know how you
Just
your train schedule.
come and talk to me if you have something to ask.
It's an Ubuntu though, and it has USB port, so you could install a dongle if you want. Yeah.
Actually,
You could in the USB stick.
yeah, because I was thinking that I should try some kind of supervised learning as well. So put some like a USB controller there and drive the car around a little bit, take a footage.
So yeah, guys, see you then in August. Have a great summer, and you can stay here until they kick you out. I think it's 8:30. Thank you.